Good morning, all.
Good morning, sir.
Yes, anyone tell me audio is clear and screen is visible to all?
Yes, sir.
Yes, sir.
Okay, we will start because already it is 8:30. Today, instead of that career guidance lecture, we will complete the chemistry because in the last week, we lost our 2 lectures. So I will complete that portion and this is recorded. So don't worry about your friends who are not attending today. I will send the recording of this lecture to all the students. I will share one link. We have to click on that link so we can get the recorded lectures. So this part is already completed in the classroom homologous series. This is very important part for the examination point of view because many times the 2 marks question it is asked on it. What is homologous series and write the homologous series of alkane or write the homologous series of alkene or write the homologous series of alcohols or aldehydes. So homologous series means what? It is a series of organic compounds. Remember, it is a series of organic compounds, each containing characteristic functional group. Means that series having one functional group. For example, if the alkane is there, it is having the alkane functional group, all having the carbon-carbon single bond. If the alkene is there, it is having the carbon-carbon double bond. If the alcohols are there, it is having the OH functional group, ROH. Remember, for alcohols. If the aldehydes are there, it is having the particular COH functional group. So homologous, each homologous series having the functional group, remember. So the main important thing in this homologous series is the successive members. Successive members are differing with CH2 group. So in this example, we can see this is the homologous series of straight chain aldehydes. So this is the COH group. We can see clearly in this table, this COH group, this is the aldehydic group. Remember, this is COH group. So this is the first member of aldehydes having the, these are the common names are given. Formaldehyde, this is the common name of the aldehyde which is having the 1 carbon. And the IUPAC name is methanol. So this is the 1 carbon is methanol, then there are 2 carbons. And what is the difference in these 2 structure? These are differing with CH2 group. Remember, these are differing with CH2 groups here. So the difference is CH2. These are the successive members. Again, these 2 members having the CH2 difference. And also it will be continued. It will be continued. So this is 1 carbon, 2 carbons, 3 carbons, 4, 5, 6, 7. See here, number of carbons are also shown 1, 2, 3, 4, 5. So this is the homologous series of aldehydes are given for the examination. They can give you to write the homologous series of alkenes. So what is the first member of alkene? Anyone can tell me which is the first member of alkene? Ethene. Ethene having the molecular formula C2H4. Ethene having the formula C2H4. What is the next alkene? C3H6. C3 alkene. I am talking about the alkene, propene. Yes, what is the formula of propene? C3 H6. Very good. So you must know the structure of this alkene, this propene. So I will show how to draw the structure of this ethene first, carbon-carbon double bond, and here is CH2. This is the condensed formula I am writing, CH2, and here is also CH2. So this is the structure of ethene. Then this is propene. Then after propene, we can write butene, pentene, hexene like this. This will be the homologous series of alkenes. Now the next point is classification based on the functional group. We are discussing the classification of organic compounds. So organic compounds are mainly classified. See, this is first one is carbon skeleton. First one is based on this carbon chelate and second one is functional group. So this classification part is completed now. And the second classification part is classification based on the functional group. This is very important. Functional group, this is the heart of organic chemistry, remember. So here in this table, some functional groups are given. So see, we have to prepare this chart at your home, but just one change we have to do. In these examples, we have to write 5 examples of each functional groups. 5 examples of each functional groups we have to write down. So first one is halide, it is given, halide. The name of the functional group is halide. It is denoted with, this is the dash and X. This dash indicates this halide is attached to another group here. So here one example is given, CH3Br, methyl bromide. Instead of this CH3, we can take here C2H5. Any alkyl group you can take. So what is alkyl group? I have explained. This CH3, it is called as R, alkyl group. We can take methyl, ethyl, propyl, butyl, pentyl, hexyl, octyl, nonyl. Also, these X are halogens, means X is equal to, this X will be fluorine, then chlorine, bromine, and iodine. So any compound with Rx, it is called as alkyl halide, remember. Any compound with this R and X, it is called as halide, alkyl halide. This is alkyl halide. And if this instead of R, aromatic group is there, ARX, it is called as aryl halide. It is called as aryl halide. For example, CH3Cl. CH3Cl, it is methyl chloride. This is the example of alkyl halide. And if instead of this CH3, I am taking aromatic benzene ring here. This is benzene. Benzene we can draw like this. And if the bromine is attached here, it is also the aryl halide. This is R group and this is X. Bromobenzene. Bromobenzene. So we can write the examples of this alkyl halides. Then second, this is completed. You can write 4 examples or 5 examples. If instead of bromine here, we can also write chlorine. See, instead of this bromine, we can write also here chlorine or iodine. If the iodine is attached, it becomes iodobenzene. So the example will be changed. So here we can also, instead of this chlorine, we can write iodine also. So we can change the halogens also. We can change the R group also. So by making this combination, we can write 10 examples. Write 5 examples of alkyl halide and write 5 examples of aryl halide. Okay, so we have to write 5 examples of alkyl halide, R, we have to change R, and 5 examples of aryl halide. It is not given here, but I have explained how to write the examples of aryl halide. Here only we have to change. Instead of iodine, we can take chlorine also, we can take bromine also. Then also we can write here positions also we can change. If any student don't having the example, he can write here, one chlorine is attached here, another iodine we can attach here. So this is also the example. Means we can attach here different X groups at the different positions. Then second, I am coming to the second functional group. It is called as cyanide or nitrile. Remember the name carefully. It is a cyanide, N-I-D-E, or it is also called as nitrile, and it is donated with dash CN bond, C triple bond N. The first member is here. It is shown in the example methyl cyanide, or it is also called as acetonitrile. So anyone can tell me the second example? Anyone can tell me the second example? Methyl, after methyl, which group comes? Dikshit, Sutar. 70, serial number 70. Dikshit Sutar, tell me. Unmute yourself. Then here also, Jay Rajankar, tell me. Say the second example. Nikam Sitij. Naule Shruti. Yes, Shruti, tell me what will be the second example of this cyanide. First example is given here, methyl cyanide. What will be the second example? Only what we have to do, we have to change the R group. We have to change the R group. Yes, tell me. Instead of here, methyl, what will be the second example? We can write ethyl also. Ethyl cyanide, then propyl cyanide. We can write the pentyl cyanide. What we have to do? Only we have to increase the carbons here. CH3CN. Then we can write C2H5CN. See here CH3CN. Second example we can write here C2H5. What is this C2H5? C2H5 is which group? Ethyl group. And the CN will be remain same because this is the functional group. We are changing only R group. This group we are only changing. After C2H5 we can write C3. Yes, what is the formula of propyl group? C3H7 or 8?
7.
Yes, very good. It will be C3H7CN. Then we can write the next example will be propyl. This is ethyl, this is propyl. Next will be butyl. So we can write as the number of carbon increases, the example will be changed. The example will be changed. After that, we can write pentyl cyanide. After that, we can write hexyl cyanide. Only 5 examples I want of each functional group. So this is completed. This is completed. Then I am coming to the yes, screen is visible. Screen is visible to all?
Yes, sir.
Yes, sir.
See what is the change in cyanide and isocyanide. In case of isocyanide, see NC bond is there, NC bond, and in case of cyanide, CN bond is there. See, so this R group is bonded to the carbon, and here in case of isocyanide, this R group or this nitrogen means the bond between R and nitrogen is there, and in case of cyanide, there is a bonding between carbon and R group, or it will be AR group. Instead of R, we can write here AR also. Aromatic cyanides are also there if the cyanide group is attached to the benzene. So what will be the name? Anyone can tell me? This is called as cyanobenzene. Cyanide is there. Okay. This is cyanobenzene, but there is a change in cyanide and isocyanide. Remember, in case of isocyanide, there is a bond between R and N. So same examples we can write. First one is methyl isocyanide. Second one will be ethyl isocyanide. Then propyl. Then butyl, pentyl, hexyl. Only we have to change these R groups. Remember these formulas. Nitro NO2. This NO2 we can write like this also. Remember, for your understanding purpose, they have shown like this: NO2, N double bond O and single bond O plus minus NO2. This is nitromethane. What will be the second example? Nitroethane. Then nitropropane, nitropentane, nitrohexane. This is RNO2 group. RNO2 means NO2 group is attached to the alkyl group. So these are the alkyl nitroalkanes. These are the nitroalkanes. Nitro group is attached to the alkyl group. It is called as nitroalkanes. And if it is attached to the AR group, ARNO2. ARNO2 means NO2 group can be attached to the aromatic system. Suppose if it is attached to the benzene ring, if it is NO2 group is attached to the benzene ring, it becomes nitrobenzene. it becomes nitrobenzene. Suppose here is NO2 group is attached to the benzene, it becomes nitrobenzene. So remember, when NO2 group is there, it is called as nitro compounds. The functional group is nitro. NC isocyanide, CN cyanide, X halide. Then in case of alcohols, we have to remember here, always this OR is OH group is attached to the R group, ROH. Instead of R, if the aromatic system is there, alcohols, these are called as phenols. Remember, when the OH group is attached to the aromatic ring, the functional group is different. It is called as phenols. And when the OH group is attached to the R, it is called as alcohols. So I have discussed many examples of these alcohols in the classroom: ethyl alcohol, then ethyl alcohol, then propyl alcohol, then butyl alcohol, then pentyl, hexyl, heptyl. Only what we have to do, we have to increase the carbons. So the name will be changed. But here, when this OH group is attached to the benzene, it is not alcohol, it is called as phenol. See, this is the benzene. And when this OH is attached to the benzene ring or aromatic ring, this is not alcohol, it becomes phenol. So there are different phenols, different OH. If the two OH groups are there, it is dihydric phenol. If the three OH groups are there, it is dihydric phenol. In 12th standard, there is a special chapter on alcohols, phenols, then on nitro compounds, then alkyl halides. So each functional group having the chapters. Ether having one chapter, then amines having one chapter, aldehyde ketones having the chapter. So in detail, reactions, nomenclature system, it is included in 12th standard, remember. So in 11th standard, what we have to do, you must know the functional group. You should identify the functional group. You should know the name of that functional group. This is important in 11th standard. In 12th standard, what we are going to do, we will, again, there is an introduction of the aldehydes and ketones, ethers, amines, nitro compounds, how they are prepared, what are the reactions of that compounds, and finally uses. So this part is included in 12th standard. In 11th standard, what is important? What is the difference in alcohols and phenols? If R group is there and the OH group is there, it becomes alcohol. And if AR is there, OH is there, it becomes phenol. So this should be identified. Alcohols, phenol should be identified in 11th standard. So in case of phenol, also we can write the different examples of phenols. But this is quite difficult to write down the examples of phenol. So one example is sufficient for phenol, but we can write 5 examples of alcohols. We can write 5 examples of alcohols, and in case of phenols, one example is sufficient. Then primary amine, when NH2 group is there, see, this is NH2 group. When NH2 group is there, when it is attached to the R group, it is RNH2. Suppose this is RNH2, it is aliphatic amine. Aliphatic amine and aromatic amine. There are 2 types of amines. When this R group is attached to the NH2 group is attached to the R, sorry, it is a primary aliphatic amine. NH2 primary aliphatic amine, and ARNH2, when AR group is there, ARNH2 is primary aromatic amine. Remember, AR means benzene ring should be there. So one example is given here, CH3NH2, methylamine. So instead of CH3, if ethyl group is taken, ethylamine, then propylamine, pentyl, same like alcohols, we can write 5 examples of primary amine. Then what is happening in case of secondary amine? One hydrogen is reduced here. See, one hydrogen is reduced, and we can write here 2 R groups or 2 AR groups. And in case of tertiary amine, all the hydrogens are replaced, and we can write here 3 R groups. Yes, see. So what is the difference in primary amine, secondary amine, and tertiary amine? In case of all these are amines are the derivatives of ammonia. Actually, ammonia having the formula NH3. NH3, this is the ammonia, formula of ammonia, and amines are the derivatives of this ammonia. So first one is one hydrogen is replaced here with one R group. So ये बन गया 1 NH R NH2. एक हाइड्रोजन हमने कम किया यहाँ का and R group, एक R group डाल दिया. Then again I am reducing one hydrogen and I am adding one another R group, R NH NHR. So this is the secondary amine. So again I am removing one hydrogen and I am adding one R group. This becomes tertiary amines. So there is a one chapter amines in 12th standard. So this is primary, this is secondary, and this is tertiary amines. Okay, examples are also given here. CH3, CH3. We can write instead of this CH3, we can change here C2H5. We can also change this CH3 group. Again, we can write here ethyl. We can write here methyl. We can write here propyl. We can write here. So by making different combinations, we can write 10 examples of this secondary amines, 10 examples of this primary amine. Then this is a trimethylamine. So all the groups will be methyl. One group is methyl. If this is C2H5, if this is C2H5, then the example will be changed. So you should understand what is the functional group. Primary amine क्या है, secondary amine क्या है, what is the tertiary amine क्या है. Okay. Then next functional group is ether. I'm coming to the next functional group, ether. See this formula, COC. COC, this is the functional group of ether. So we can write here CH3, CH3. This is one example. Both are ethyl groups. So it is a dimethyl ether. One ethyl, one methyl, it will be ethyl methyl ether. So by changing these groups, which groups are groups, we can write the different examples of ethers. So if these two CH3s are replaced with two ethyl groups, the name will be diethyl ether. One CH3, one C2H5, the name will be ethyl methyl ether. If one CH3 and one propyl group is there, then the name will be ethyl propyl ether. So here also we can write the different examples of ethers. Aliphatic, again there are aliphatic ethers and aromatic ethers, remember. Instead of this CH3, if this one benzene ring is there, that is called as phenyl group. pH is phenyl, again this O, and again pH group. So the name will be diphenyl ether. Diphenyl ether, or you can change one phenyl group here and one ethyl group, PHO CH3. So here pH group is what? This pH group we can draw like this also, remember. Means this is a benzene, but with one hydrogen less. One hydrogen less. So what is the formula of benzene? Is C6H5. Sorry, C6H6. This is the molecular formula of benzene. But in case of phenyl, one hydrogen is less. It becomes C6H5. 6,6H5 group is called as phenyl group. Remember, C6H5 group is also called as phenyl group. Okay, so you must know how to identify the ether group. Oxygen is there in between two carbons. Then aldehyde, just I have already introduced this aldehyde group, COH group. Remember, this COH group is always terminal. This will not be in between. So one important characteristics of these aldehyde groups are always terminal. Either it will be on the right hand side or it will be on the left hand side. ये बीच में कभी नहीं आएंगे, in between. But the ketones can be in between. because CO group we can insert in between, but in case of aldehydes, it will be always on the terminal carbon. Acetaldehyde, one example is given. Acetaldehyde having the 2 carbons here. See, there are 2 carbons. But we can write here one example. First example, HC double bond O. HC double bond O. H. What is the name of this aldehyde? Anyone can tell me the name of this aldehyde? HC double bond OH. This is the first member of aldehyde. It is called as formaldehyde, common name. Huh? And IUPAC name is methanol. IUPAC name is methanol because 1 carbon is there, and in case of aldehydes, it ends with Al. Methanol, N-A-L. Methanol. Now, if this is methanol, then what will be the IUPAC name of this compound?
Pro.
2 carbons only. If the 2 carbons are there, it becomes ethanol. If the 3 carbons are there, it becomes propanol. If the 4 carbons atoms are there, it becomes butanol, then pentanol, then hexanol. According to this, we have to write the IUPAC names of aldehydes. But here, the names are not important. Identification of functional group is important. I'm talking about this particular table only. Okay. So 5 examples of aldehydes, 5 examples of ethers, we have to write down 5 examples of primary amine, 5 examples of secondary amine, 5 examples of tertiary amine, then 5 examples of aldehydes. Now I'm coming to the ketones. So ketones are very easy. This CO group is there. This CO group. CO is C double bond O group. Remember, CO we can write like this also, or if the space is available, we can write this CO also like this. So first example, it is given here. Now tell me, identify whether it is a ketone or aldehyde. I'm writing here CH3, CO, CO and H. Tell me, it is aldehyde or ketone? And I'm writing another example here, CH3, CO and CH3 again, CH3. Yes, which is aldehyde, which is ketone in these 2 examples? How to identify aldehydes and ketones?
They have hydrogen and oxygen.
If COH group is there, see, if the COH group is there, it becomes aldehyde. And if only the CO group is there, no hydrogen is attached to this carbonyl carbon, they become ketone. So this is very easy to identify. Mute yourself. Mute yourself. It is very easy to identify whether it is aldehyde and ketone. So this is a ketone. Why it is ketone? Because CO group is there. CO group is there, and this side it may be R group or it may be R group. So the dash indicates this CO group is bonded. It may be R group. It may be similar. 2 R groups may be same, or one is different. It is R dash. See here. Both the R groups are same here, CH3, CH3. The name is acetone. Now, if this is CH3, it becomes C2H5. The name will be changed because the 2 R groups are not same. So, in this case, this is called as asymmetrical ketone. If the 2 R groups are same, it becomes symmetrical ketone. And if the R groups are different, it becomes unsymmetrical ketone. So, the name will be changed. So, I'm talking about this R group. If instead of R group, we can take aromatic groups also. Suppose this is a benzene. Instead of benzene, I can write here pH group. Now, you are familiar with this pH group. pH group is phenyl group, CO. Here I am writing ketonic group, CO. And here I am writing CH3. So this is also the ketone. Because what is the functional group of ketone? CO group should be there. Whether it is attached to the R group or whether it is attached to the AR group, it doesn't matter. This doesn't matter, but CO should be there. This carbonyl group is there. So carbonyl group, when it is bonded to any R group or any same R groups or different R groups or AR groups, it becomes ketone. This is very easy to identify COH and CO. Student makes confusion between aldehydes and ketones. So don't make confusion. Write 5 examples of aldehydes, write 5 examples of ketones. So names are not important here. Write the examples, write the formula. You can write the formulas. So in the next slides, in the next part, I will also teach you how to give the names. But here in this table, what is important? Identification of functional group is very important. Okay, the names are not important. In the next part, I will show how to give the names. Common names are different. IUPAC names are different. So we completed here 12 functional groups. We completed here 12 functional groups. These are the different functional groups, how to identify the nitro, alcohols, phenols, primary amines, secondary amines, and aldehydes, ketones. Some examples are also given here. Mute yourself. Just a minute. Yes. In case of carboxylic acid, there is a little bit change in aldehydes and carboxylic acids. So here also students get confused between aldehydes and carboxylic acids. So what is the change in aldehydes and carboxylic acids? There is COOH group, remember. COOH group means CO group is ketonic, OH group is alcoholic, but there is a combination of COOH group, remember. So here it is not COH group. COH hai, so it becomes aldehyde, but it is not COH. It is one oxygen is added here. COOH group is called as acidic carboxylic acid, remember, carboxylic acid, COH. And here we can write R group, any R group, if it is CH3, this is a methanoic acid. Sorry, it is a, when 2 carbons are there, it is ethanoic acid. In case of carboxylic acid, it ends with OIC in IUPAC nomenclature system. And in case of common name, it ends with acid. So first member is formic acid, remember. H, CO, OH. Now tell me this is aldehyde or this is carboxylic acid. Anyone can tell me. HCOOH. This is aldehydic group or this is a carboxylic acid.
Carbolic acid.
Yes, because this COH, it is the functional group. This COH, it is the functional group. Don't consider this COH. Don't consider this COH group. Because COH group, when the OH group is bonded to the CO, it becomes carboxylic group. So we can write the 5 examples of this carboxylic acid. Second one is, if the 1 carbon is there, it is a formic acid. Then 2 carbons are there, it is acetic acid, then propanoic acid, then butanoic acid, then pentanoic acid. The structures are similar. If you understand the structure of alkane, you can write the structures of all functional groups. Only what we have to do, only we have to increase the carbons. This is the main thing in case of organic compounds. Only we have to increase the carbons. Now I'm coming to the next functional group is esters. So there is one change, COO group here. H is not there. H is not there when the COO group is there and If this is bonded to the R group, or it may be bonded to the R dash group. After finishing this lecture, again we have to click on the same link. I will continue. Okay, because only 1 minute is remaining here. Again, we have to continue. So these groups may be same or these groups may be different. R group and R dash group. Here, one example is shown here. CH3 is there. This is a methyl group and this is a C2H5 group. So these groups are different. These groups are different and the name is ethyl acetate. This is the common name. Ethyl acetate is the common name. I will also teach you how to write the IUPAC names of these esters. It is very easy because one group is attached to the oxygen and another group is attached to the CO group. So the group which is attached to the oxygen, we have to take first.